Now we are going to discuss about electric flux density. The electric flux density is defined as the electric flux per unit area. D is equal to psi by A in coulomb per meter squared, where psi is the total electric flux, A equal to total surface area. Now come to the unit. The unit for electric flux density is coulomb per meter squared. Which unit is coulomb? Charge unit is coulomb. Which unit is meter squared? Area unit is meter squared. Therefore, D is equal to Q by A. Now you just look at these two formulas. Here D is equal to psi by A. Here D is equal to Q by A. Now you just observe that is the psi equal to Q? Yes, you have to verify it. That is the Gauss's law. Now for the sphere, the area is 4 pi r squared. Therefore D is equal to Q divided by 4 pi r squared. Now you know the basic formula for the E equal to Q divided by 4 pi epsilon naught into epsilon r into r squared. This is the formula for E. This is the formula for D. Now you want to compare these two formula. D is equal to Q divided by 4 pi into r squared, which is equal to epsilon naught into epsilon r into E. Just observe this and this. Here is the medium is not involved. Here is medium is involved. You can also express the electric flux density in vector form. Vector form of electric flux density, D is equal to d psi by ds into AR vector. Now we will discuss about Gauss law. The statement for Gauss law is the electric flux passing through any closed surface is equal to the total charge enclosed by the surface. That means psi is equal to Q. Just look this figure. Consider the small element of area ds in a plane surface having a charge Q and a point P be the point in the element. At everywhere point on the surface, electric flux density D will have ds. Let the ds is making an angle. That angle is theta with surface ds. Now the electric flux crossing the surface ds is the product of the normal component ds and ds. So this, or you can easily remember that D is equal to d psi by dA or ds. So from this one you want to find out the d psi value, which is equal to d into ds. So here is this d is the normal value. So d psi equal to ds normal into ds. You know the formula for A dot B. So mod of A mod of B into cos theta. So here is this magnitude is ds, this magnitude is ds, then cos theta. Therefore t psi equal to ds into ds. Now you want to find out the pi value only. Therefore we are integrating on both sides. Now consider the charge Q at the origin, and the point in the spherical coordinates are r theta pi. Now this is the r directions, this is the phi directions, this is the z direction. Now the electric field intensity due to the charge Q is E equal to Q divided by 4 pi epsilon naught into epsilon r into r squared. The electric flux density D is equal to epsilon naught into epsilon r into E, which is equal to Q divided by 4 pi r squared. Now you just consider only the small area on the surface of the sphere at a distance r from the origin. Yes, this area. Now what is the surface area here? R is a constant. Yes, this directions R is a constant. So you have to remember the coordinate system formulas. You just pick the formula from there. ds equal to r into d theta into r into sin theta into d pi. Yes, could you remember this formula? Yes. Simplify that, which is equal to r squared into sin theta into d theta into d pi. The electric flux size equal to closed surface integral of S into D into ds. Now you have to substitute this D value. D is equal to Q divided by 4 pi R square. Then ds equal to R squared into sin theta into d theta into d pi. You have to cancel the common factor. Then the remaining is size equal to Q by 4 pi integral sin theta into d theta into d pi. Here is double integral. So you have to substitute the limit for each. So how to identify that? Again, you can recall the coordinate system. You know the limit for theta. The limit for theta is 0 to pi and the limit for pi is 0 to 2 pi. You just substitute that limit here. Now integrate it. Size equal to Q divided by 4 pi integral pi equal to 0 to 2 pi integral theta equal to 0 to pi sin theta into d theta into d pi. First integrate for this term. So what is the integration of sin theta? Minus cos theta. Yes, minus cos theta. So what is the limit? 0 to pi. You have to substitute that value. So minus cos of cos pi minus cos 0. If you are substituting and simplifying that value which is equal to 2. Now size equal to Q divided by 4 pi into integral 0 to 2 pi into 2 into 2 pi. Now you have to integrate for d pi. So if you are integrating this, you are going to get only pi. So this limit is 0 to 2 pi. So substitute upper limit minus lower limit. So 2 pi minus 0, you are going to get 2 pi. So already here is 2 is there. So 2 into 2, 4 pi. 4 pi and 4 pi is going to get cancelled. Finally you are going to get Q value. Now the electric flux crossing the surface is equal to the charge enclosed by the surface. Now the electric flux crossing the surface is equal to the charge enclosed by the surface. The Gauss law can be stated in the point form also. The divergence of electric flux density is equal to the volume charge density. That means del dot D equal to rho V. This is the point form of Gauss law. Thank you.